Welcome to Mimi's Math Channel. Today I will help you derive the unit circle. So we're going to start off by making sure that we divide each quadrant into 3 different sections. And we're going to do that by color coding. What you will notice is each quadrant is worth 90 degrees. So let's go ahead and label our axes. Left and right is going to be my x-axis, and it starts with 0 degrees. So this is my 90-degree angle. And then once we go to the next side, it's 180 degrees. We're just adding 90 each time. And then the next one is 270 degrees. And the final one is 360 degrees. Now that we have our axes labeled, I'm going to go to the blue, and that's going to be where I split this 90 degree in half. That's going to be 45 degrees. Now I'm only going to focus for now on everything that's blue. We're going to go back to what we learned in geometry about special right triangles. We had a 30, 60, 90 triangle and a 45, 45, 90 triangle. So 45 is the only odd number between those numbers I just mentioned. So that's what we're going to do for each quadrant. We're going to multiply by odd numbers. So what you will notice is once I multiply times 1, 3, 5, and 7, each of these numbers end with a 5. And this is going to be so corny, but the way I remember the ones that's directly across from each other is because 2 plus 2, if I replace that, that would be a 4. So like 45 and 45. Now this one, you just have to know that 45 times 3 is 135. So the 45 times 3, and just put a 1 in front of it. So 1, 3. And then if I go to the opposite quadrant, I swap those around, 3, 1. So now what I'm going to do is go to the green, which is going to be my 60 degree. For my 60 degrees, I'm going to multiply it times 1, times 2. 3 is already taken, times 4, and then times 5. So next I'm going to take my 30-degree angle, and then I'm just going to keep counting around 1 through 12. Some of the numbers have already been taken up. The only ones that I'm going to skip are anything that's related with 45. I'm going to count the 30 times 1, times 2, times 3, times 4, skip this one, times 5, times 6, times 7, skip 45, times 9, times 10, skip, times 11, and then times 12 is going to be this one. So that's how the 30s work. I see that each quadrant has 3 angles inside of them, and each one is color coded because it's going to link back to my reference angles. My reference angles are going to be positive, and they're going to be acute, which means they're less than 90 degrees. Okay, now that I have all of my degrees, now I want to go on to my radians. What I'm going to do is start with my axes. For 0 is just 0. I did teach you in another video how to go from degrees to radians, so we're going to go ahead and do that with the 91. Anything on axes is going to count, and the denominator is going to always have a 2 under it. So what I mean by that is I start off with the 0, and then for 90 I'm going to have 1 pi radians over 2. Then I'm going to go to 180 degrees, and I'm going to have 2 pi radians over 2, which is pi radians. Then I have 3 pi radians over 2, and finally I have 4 pi radians over 2, which simplifies to 2 pi radians. Pi radians is equal to 180 degrees. If I were to substitute 180 in for pi radians, you would notice that the degrees would actually become 360 degrees. So now we're going to go with 45 using the same formula, and I see that it's going to be pi radians over 4. So this time any degree that's associated with 45 degrees is going to have a denominator of 4. And I remember that because both 45 and 4 have the same number. So when I'm talking about 45 degrees, I am always going to use odd numbers. I want to go to 60 degrees, which is pi radians over 3. So this time I'm going to use those same numbers I used a few minutes ago, 1, 2, 4, and 5. So I have pi radians over 3. And then if I moved over to the next one, I am going to have 2 pi radians over 3. And then the next green one, 4 pi radians over 3. And then 5 pi radians over 3. So if you forget or you're trying to figure out, well, how am I going to remember that? Remember we did 60 times 1. So that's for the 1. 60 times 2, 60 times 4, and then 60 times 5. And all of them have to have this pi radians over 3, because if I ask you what's the reference angle in radians, this is what's associated with each one of these reference angles. And then the last one that we're going to do is going to be 30 degrees. We're left with pi radians over 6. And now I know that everything associated with 30 degrees is going to have a pi radians over 6. Well, we did the 30 times these numbers here. But it really will make more sense if you understood that the entire circle, with the exception of the 45-degree angles, is counting by 1/6. We really have 1/6, 2/6, 3/6. Well, 3/6 simplifies to 1/2. 4/6 simplifies. This is going to be 5/6. This is 6/6. This is 7/6. This is, skip that one with the 4. So 8/6, 9/6. You have to simplify. Then we just keep counting. 10/6. Skip the ones that have a 4. 11/6. And then 12 pi radians over 6, which we see that 12 divided by 6 is going to leave us with that 2 pi radians. Now we see that we have all of our radians. We should have 3 per quadrant. So there's 3, 3, 3, 3. In addition, we should have the axes. So 2 on the x-axis, 2 on the y-axis. So the last thing that we're going to talk about are the actual coordinates. Once we're going out and we're talking about a unit circle, it's just one unit. So left and right, we're going to show x first. So we're going to go out 1, and then we do not go up or down. Then once we go to 90 degrees, we are going up, but we're not going left and right. X goes first as 0, but we went up, which is positive 1. I am now still going left and right, except I'm going negative. So this is -1, 0. And this time I'm going down. So it's 0, -1. Now I'm going to find the coordinates for each one of these degrees in radians. In geometry, we learn rules for special right triangles, 45, 45, 90, and 30, 60, 90. All right, so this is going to be useful because sometimes you cannot use your calculator to find the information you're looking for because it only gives you decimals. And when we are setting up our unit circle, we want to have fractions and radicals. You also need to know that cosine represents x, sine represents y, and tangent represents y over x. So what this means is, as a coordinate, if I write x and y, the cosine comes first and then the sine comes second. Just think of your alphabet, and that should help you to remember which is which. C comes before S, X comes before Y. If I am talking about the coordinates of 30, what I want to do is recognize that there is actually a triangle here. If I were to take the 30, we'll go with 30. It's for each one. If I did 30, 45, or 60, all I'm going to do is just go from the center of the circle to the circumference or the edge of the circle, and that's going to create a 90-degree angle. And the only thing that I know is that my radius is 1, and I know that because I've already made the coordinates for my axes. No matter where I go, my radius is going to be 1. When you're looking at it here, it gets busy, so what I typically do is just take the triangle out. I'm just going to label it. I just need to know, if I'm using my rule, what the short side is, long side, and the hypotenuse. Your hypotenuse is always across from your right angle symbol, and my rule tells me for my hypotenuse that it's going to be 2 times the side. My short side is the side across from the smallest angle, and then my long side is going to be, this is 60 degrees, whatever's across from that. The only thing that I do know for sure is my hypotenuse is 1. The way I wrote that formula is hypotenuse is 1. Now I just need to find my side, which is 1/2. Remember, up and down means y. I'm going to follow my rule that says to take whatever your side is and multiply that times √3. And you're just multiplying across. This is √3/2. And that represented my long side, which is left and right, and that's my x value. And then I'm going to do the same thing for 45 degrees and 60 degrees. You cannot have a radical in your denominator, so I'm going to rationalize it, and that simply means that I'm going to multiply the numerator and denominator by what I'm trying to get rid of. 45, 45. The tick marks tell me that once I find the answer for one side, I also found the answer for the other side because they're exactly the same. So now what I would suggest that you do is label your quadrants and the signs for those quadrants. So the reason this is going to be helpful is because now that you know your first 3 sets of coordinates, all you're going to do is reuse the same information by reflecting over the y-axis, reflecting over the x-axis, and then again reflecting over the y-axis, and using the signs that go with each one of those quadrants. So the greens go together, blues together, pinks together, so on and so forth. So this is what it will look like once I reflect over the y-axis. So what you should notice is I have the same coordinates across from each other. The only difference is these are both positive because that's what x and y should be. And then here the x's are all negative and the y's are all positive. You should also notice that I'm counting from 0 for my x's, 0, 1, 2, 3, and then back up on my y's, 0, 1, 2, 3. Everything is going to have the denominator of 2 when I'm counting my coordinates. The only thing that's different is all of the numerators should have a square root on top, except 1, because what is the square root of 1? It's 1. What's the square root of 0? It's 0. Now I'm going to take the coordinates from quadrant 2 and I'm going to reflect it over the x-axis into quadrant 3. So notice the coloring, and this is what it looks like. So now I see the pink and the pink that go together. They both start with 3. So now I'm counting down 3, 2, 1, and then back the other way. 3, 2, 1. I have just reflected over my x-axis. In addition to my x values are negative, my y values are negative because I'm in quadrant 3. So now let's take the coordinates of quadrant 1 and reflect it over the x-axis into quadrant 4. Or you could have taken the coordinates from quadrant 3 and reflected it over the y-axis into quadrant 4. This is what the coordinates will now look like. So now I have positive x's and negative y's. I'm still counting 1, 2, 3, and then once I reflect it, it's 3, 2, 1. Now I have to go back up in the other direction, 3, 2, 1. Everything has a denominator of 2 all the way around. Everything has a square root on the top except the square root of 1 because it's 1. So once you learn quadrant 1, if you know how to reflect over your y-axis and your x-axis, you know how to find your coordinates of the unit circle. I'm going to focus on learning tangent. So tangent is y over x. And because all of my denominators are 2, when I take the reciprocal, what's going to happen is those 2's are going to just go away. So the easiest way to do it is to take your y numerator and divide it by your x numerator. So if I wanted to find tangent of 30, I know that these are my coordinates. So I'm going to take y and I'm going to divide it by x. So if I ask you what is the tangent of 30, this is what you would tell me. Tangent of 45 degrees, the y, and divided by x of the numerator only. And then the last one is the tangent of 60 degrees, which we know is going to be y numerator, which is root 3, and divided by the x. These are the 3 that I would commit to memory because they won't change. The only thing that will change is the sign. Please remember to like and subscribe. Have an amazing day.